Hi everyone, my name is Rasul. I work in MPC research team of privacy and scaling explorations. And today I want to talk about MPC tooling or how we can create MPC apps. So what exactly I'm going to go over is like first short introduction, what is MPC? Then I'm going to talk about applications of MPC. And then I'm going to cover tools we work on in our team that allow people to create MPC apps. And then short example, interesting example of using these tools. So what is MPC? MPC is an interactive protocol that allows parties to jointly compute a function or their inputs while keeping those inputs private. So let's imagine that we have a public function f that takes two parameters, x and y, and let's say party 1 provides x parameter, party 2 provides y parameter, and parties will be able to compute the output of this function while keeping their individual inputs private. So there are two kinds of MPCs. First one is app-specific, and second one is general-purpose MPC. So app-specific protocols, MPC protocols, are designed to represent one specific function. So let's say threshold signatures, Shamir secret sharing, and PSI, and many others. And general-purpose are designed to represent any function, including all the app-specific protocols as well. So there are many applications of MPC. I'm going to mention a few examples. So it's like privacy preserving machine learning, cost narcs, MPC stats is another great project that PEC team works on, and etc. So first tool I want to talk about is called CircumMPC. CircumMPC is basically a project is a fork of Circom. It's a famous ZK DSL, but it compiles to universal MPC format called Bristol Fashion Circuit that can describe Boolean and arithmetic circuit. So why we chose Circom is because many ZK/cryptography devs already know Circom, and it will be easier for them to create circuits in Circom. And there's also a big number of circuits written in Circom already. For example, CircumLibML, and they can be reused without changing the code. And that's actually what we did in PEC as well. We just took CircumLibML, Kathy's library, and we were able to run MPC circuits, ML, in MPC. Another tool I want to talk about is called Summon. Summon is a language for collaboratively summoning computations. And it's another tool that my teammate mostly works on, Andrew Morris. And Summon is TypeScript-like DSL, similar to CircumMPC, with a goal for user-friendliness. It can be used from or in TypeScript, and therefore it allows to build everything end-to-end in TypeScript. So if you know Cursive team, they already use a Summon tool as well in their apps. And the last tool I want to cover is called CircumMPSpeeds. So first of all, MPSpeeds itself is a big framework that people can use to create MPC apps, but it might be a bit hard for beginners to start with it. So what we do, CircumMPSpeeds is basically a transpiler from Bristol format that generated by Summon compiler, by CircumMPC, and a transpiler from Bristol format to .MPC representation that is required to run the circuit in MPC with MPSpeeds backend. And this project shows an example of running CircumLibML machine learning circuits in MPSpeeds, and you can find benchmarks and every information about this in the repo. And yeah, as I said, the same tool can be used to transpile circuits generated by Summon as well, not only by CircumMPC. And the last thing I want to talk about is an example of using these tools, specifically Summon. It's a matching game for friends and lovers that Barry Whitehead was talking about last year on DevConnect Istanbul. It's called 2PCs for Lovers. So basically, you can play with your friends or with your lover, and you can choose love. But if you choose love, but the result is friendship, only you will know about your feelings, even if your friend knows advanced cryptography. Yep, and you can try it here. Yep, that's it. Thanks for coming. You can find me by my username, Rasul. Yep.
Thank you, Rasul. Any questions? Oh, there's one. I probably need some help. No? Do you want to try?
Yeah, let's go. I leave mic here. There? Sorry. Sorry, Georgie.
That was a good direction, so.
Okay.
I have a question. Did you explore using MPC for building interoperability or bridges?
No, actually. No, I don't think so. I don't think so, no.
Do you have an idea?
Like, for example?
Opinion? Yeah, I mean, building interoperability protocols with MPC.
No, we weren't doing this. We mostly were focusing I work mostly on Circum MPC. So we were focusing on privacy preserving machine learning, like mostly. And yeah, not on that case yet.
Yeah, sure. I mean, we are just exploring it and getting into it. So wanted to see like more opinions and builders around that. Okay, thanks.
Sorry if I didn't answer.
We see a question over there. Yeah.
Oh, this is a mic? Oh, sorry, I didn't know this was a mic. Circom usually targets an R1CS backend, and so I'm assuming all of these other tools also. And it's kind of, I guess my question is, do you pay a price for that? Are there other MPC arithmetizations that you work with, or is there something inherently related to the Circom tool chain that you find useful here?
Sorry, your question is, do we have...
So my question is that... sorry. Oh, okay, sorry. I was not here when the dice was introduced. But my question is that Circom is typically targeting an R1CS backend, and so I'm assuming all these frameworks and toolings are doing the same, but there are some pretty clever other arithmetizations, and I'm wondering if MPC is solely in this domain, or you can make use of other things like Plonk or other arithmetizations.
Yeah, I think it's like, as I mentioned, it's a fork of Circom, and we don't target R1CS. Instead, we target Bristol format. Bristol format is a universal MPC format that can describe arithmetic and Boolean circuit. And yeah, it's just like a super simple format. And from this format, you can already, I don't know, also transpile it to whatever backend you want. So for example, MPZ library is like another library that PSC works on. You can target this library. You can target MPSpeed's library, yeah, etc. Yep.
Let's give a big applause to Rasul.
Thank you.